Let's go ahead and talk about the unit circle, first starting with radians. So radian is the opening created by laying the radius of a circle along an arc, creating this opening, which is equal to 1 radian. Okay, a diameter is 2r, and then the circumference of that circle is 2 pi r. If we try to figure out how many radii do we lay along the circumference of a circle, okay, that's going to give me 2 pi radians that go all the way around one circle. Again, what is a radian? It's an opening created by laying a radius along the arc of a circle, creating 1 radian angle. Now that takes us into the unit circle. Why is unit circle so important? Because it allows us to go ahead and find the sine, cosine, and tangent of any angle based on this one kind of formalized, unitized circle. So let's go ahead and take a look at, we just said that 2 pi radians envelops the whole circle. So now this is just a counting system. Okay, we know the regular degrees. So we know that from here to here is going to be the same length as from here to here in terms of angle. So I'm going to go ahead and draw the 45-degree track. And then we've got the 60-degree track or the 30-degree track. Look at the degrees first. So on our unit circle, this is going to be 0 degrees. And then this right here is going to be 90 degrees, stuff we already know. Now, if we take a look at the pink 45-degree lines, we're going to cut 90 in half. That creates 45 degrees. Okay, 45, 90, and then 90 plus 45 is 135. Okay, going on, we have 225, 270, and then we have 315. Okay, then we go back to 360, okay, for a full circle. Now go ahead and take a look at our 30 angles. So this is 30, 60, 90, keep going. Perfect. That's degrees. Now let's go ahead and take a look at radians. Because it takes us 2 pi radians, which is equal to 360 degrees, we can base all of our radian values off of that measurement. So this is my 0 radians. Now, all the way around is going to give me 2 pi radians. So now I'm going to take a look at, all right, what is half of 2 pi? If I cut 2 pi in half, I'm going to get 180 degrees, which is pi radians. So this right here is pi radians. Now, if I cut that pi radians in half, I get pi over 2. Okay, so now we introduce our counting method. So for radians, we have 0, pi over 2, that's 1 pi over 2. This could also be written as 2 pi over 2, which is just pi. This is 3 pi over 2, and then this is 4 pi over 2. Oh, 4 pi over 2, which can be written as 2 pi. All right, so all the other radian values are simple counting measures. So if we take a look at the, if this is pi over 2, if we cut that in half, again, we have the 45-degree track, we're going to call the pink track. So if I take pi over 2 and I cut that in half, I'm going to multiply that by half, I get pi over 4. So now I'm just going to go ahead and I'm going to count. So I have 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 5 pi over 4, 4 pi over 4, which is just pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, right? Which is the same thing as 2 pi. Now, let's take a look at our 30-degree track. So if there are 1, 2, 3, 4, 5, 6, so if there are 6 within 180, that means there are pi over 6 sections in 1 pi radians. So this is going to be 1 pi over 6, and this is going to be 2 pi over 6. If we reduce that, we're going to do pi over 3. This is 3 pi over 6, right? Pi over 2 is the same thing. So this is 4 pi over 6. This is 5 pi over 6. Right? This is 6 pi over 6, again, still just pi. This is 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 12 pi over 6. Again, which is just 2 pi. So that is how we do our radian measures. Now, so within our unit circle, what we have x and y values. For example, if I take a look at this right here, the definition of a unit circle is it has a radius of 1. So that means this point right here is x is 1, y is 0. This point right here has a point of 0, 1. The x value is 0, the y is 1. Then this one would be corresponding negative. Negative 1, 0. Then this one would be 0, negative 1. Okay? So each of these values is an x and a y value. Let's take a look at what would this point be right here. Okay? So what I'm going to do is I'm going to take a look at a special triangle. So we know that this triangle right here, if I were to just draw this triangle, emulates this triangle. This is a special right triangle, a 45, 45, 90 triangle, which we know that the proportions of the sides of a 45, 45, 90 triangle is the legs are the same, right, isosceles, but then we go ahead and we multiply the leg by the square root of 2 using the Pythagorean theorem to get the hypotenuse. So if we know that the hypotenuse is equal to 1, that would be right here because we know the unit circle has a radius of 1. The question is, what is this value right here? What is this value? That is going to give me my x and y value of that point. So if I go ahead and I divide by the square root of 2, I can't leave it as 1 over the square root of 2, right? I can't have that square root in the denominator. So I've got to rationalize the denominator. So I end up getting the square root of 2 over 2. So this becomes square root of 2 over 2, square root of 2 over 2. Now, what's great about that is every 45-degree angle, okay, or pi over 4 radian measure, is going to have, this is the x and y value, maybe just negative or positive. So this one right here is going to be negative square root of 2 over 2, positive square root of 2 over 2. Because that's the negative x value, positive y value. Okay, this right here is going to be negative both ways because the x and y are both negative. This one's going to have a positive x value, but a negative y value. Okay, so that is how and why the x and y coordinates of every pi over 4 radian is square root of 2 over 2. Let's go ahead and take a look at this right here. So that value right here has an x and a y value. The question is, well, what is it? This right here is a 30-degree angle. Pi over 6 is a 30-degree angle. So what that means is we have ourselves another special right triangle. So if I were to draw this triangle right there, this would be the y value right there. So I can actually just change this to y if I wanted. Okay? And then this would be the x value. Okay? So it emulates that triangle. Now, what's special about this triangle is it's a 30, 60, 90 triangle. What that means is the proportions of the side, or the ratios of the sides are going to be similar. Whatever the short side is, we multiply that by 2 and you get the hypotenuse. And then whatever that short side is, we multiply by the square root of 3 to get the long side. So the long side is always across from the 60 degrees. The short side is always across from the 30 degrees. So what that means is we are going to find x by knowing that the hypotenuse is equal to 1, right? That's the radius. So if the hypotenuse is 1 and that equals 2x, then we know that x is a half. So this right here, this length right here is 1/2. Now, I know it's a little confusing because I said x, but this is the y value right here. This is how high it is up. Okay, so that's the y value. So the question is, what is this x value? Well, if I know that x is 1/2, then the x value just becomes 1/2 times square root of 3. We call that square root of 3 over 2. Okay, square root of 3 over 2. So this is the x, and that's the y value of the unit circle. Now, let's go ahead and take a look at how does that value mirror. Well, this point right here, if I go ahead and I erase the rest of this. This point right here is the same triangle, just mirrored or transformed. So this is now the short side. The x value is the short side. So you have to think of yourself, which one's the short side? Because that's going to be the 1/2. The long side is going to be the square root of 3 over 2. So this is 1/2, and then the y value is square root of 3 over 2. So we go over here. All right? Well, the long side is the y value, so that's square root of 3 over 2. But here, my x value is negative. And then based on that relationship, long side is x. Okay, I can go ahead and I can find every x and y value of the unit circle based on this pattern. So this is going to be negative square root of 3 over 2, negative 1/2. This one right here is going to be short side is the x value. This one right here, the short side is the x value. Again, we're not memorizing anything because we can always go back to these relationships. So the unit circle is not about memorizing. And then the long side here is square root of 3 over 2 for the x. And then negative is going to be negative 1/2. Okay. So there you have it. Unit circle, very easy. Why is the x value the cosine? So if I take a look at this triangle. So this triangle emulates this triangle right here. Okay, this is 30 degrees. If I knew the hypotenuse is 1, I'm going to call this the x value and the y value because it essentially is. This is the y value and this is the x value. Go ahead and do SOHCAHTOA, right? Sine, cosine, tangent, opposite, adjacent, hypotenuse. SOHCAHTOA to go ahead and figure out what the x value is of this. Well, you'd say, okay, I'm going to take this is the adjacent side, this is the opposite side, and this is the hypotenuse. So if I want to go ahead and find the x value, I'm going to take I'm going to take the cosine of 30 degrees equals adjacent over hypotenuse. So my x value ends up just equaling my cosine. That's equally as true if we're looking at sine. So if I wanted to see this y value, I'd say, okay, that would be, so the sine of 30 degrees would equal opposite over hypotenuse, which is y over 1, which is y. So the y value equals the sine value, the x value equals the cosine. Remember, it's alphabetical, x before y, cosine before sine. There's the unit circle. Very easy. Very easy.